Hey guys, this is Matt Goldenberg here, and I wanted to put up a quick critique of Paul Sztorcs' Drivechain video. Drivechain is a suggestion that Paul has for how sidechains should work. And in the Drivechain video, one of the things he argues is that reputation-based oracles on Ethereum are impossible. Now, my name is Matt Goldenberg, and I'm actually building a reputation-based oracle on Ethereum, so you might imagine that I have some slightly different views from Paul. Now, that being said, I want to make clear that this is not an attack on Paul. I actually really admire Paul. I find in him a kindred spirit. We both are collecting mental models and trying to use those mental models to better the world. And just like Martin Luther put up his 95 Theses for everybody to critique and everybody to discuss, that's what Paul did with his video. And that's what I'm doing with mine. I'm critiquing Paul's, and I expect people to critique me. Because if what I'm doing is wrong, if it really is impossible to build what I'm building on Ethereum, then I'll stop. And I'll do something else that will really help the world. So please feel free to critique me. So the first thing that Paul argues in his videos is that externalities matter. And that when smart contracts hook into Bitcoin, they're externalities. Therefore, the Bitcoin miners who have stake in this should have a say in what happens. And I agree, externalities matter. And I think that permissionless smart contracts are actually a better way to handle these externalities than this permission system that Paul has. And I'll get into that argument later. So what Paul says, and I agree with this, is that not all smart contracts, when you add them together, are going to add to the system. Some smart contracts can actually interact with each other in ways that are problematic. You can get feedback loops and all sorts of crazy things going on that are problematic. And what he goes on further to argue is that this could be so problematic that it could destroy the entire ecosystem. So he gives the example of nanobots and gray goo. He gives the example of spam, and he gives the example of invasive species. And this is true. You really have to be careful with these types of feedback loops, and you really need a system to deal with. Now, what I'll argue later is that what Paul suggests with Drivechain is a very, very fragile way to prevent these things, and fragile systems, given enough time, always fail. Now, with permissionless smart contracts, what I'll argue is that we actually create an anti-fragile system to prevent these types of feedback loops and problems. And anti-fragile systems improve over time as the system has issues. So I'll get into all that later. Now here's our first significant disagreement with Paul. Paul says non-trivial smart contracts can never be permissionless. He wants permissionless innovation without permissionless implementation. And to me, this idea of permissionless innovation without permissionless implementation fundamentally misunderstands how innovation works. Because I'm going to argue that this is nearly impossible. And here's why. I'm going to give you two models of innovation. And I'm not going to use economist models because economist models are just not that well developed in the area of innovation. I find business strategists have much better models of this. So the first one I'm going to talk about is Clayton Christensen's model of disruptive innovation. So in Clayton Christensen's world, there's two types of innovation. One type is called a sustaining innovation. A sustaining innovation is a small innovation that just incrementally improves on your product, makes it a little bit more complex and a little bit more featureful. And what Clayton says is that the established players are always making these sustaining innovations, getting a little bit better and a little bit better and a little bit better. And unwittingly, they're adding complexity to their own systems. What the disruptions are is that somebody realizes that in creating this complexity, these companies are providing a space for a more simple solution that serves the lowest part of the market that may be priced out or simply complexified out of this really complex solution. So disruptive innovation comes in And it says we're going to simplify this. We're going to take everything that person learned and we're going to create a new solution. And then we're going to start doing that sustaining innovation. And the system happens all over again. Now, what is needed for those sustaining innovations is interaction with the market, because you can't create an innovation on top of what you already have without realizing, oh, here's a problem. Here's what's happening. So you need interaction with the market. In terms of the disruptive innovations, those start out, again, just serving a really small part of the market. They don't seem that exciting. They don't seem that interesting. And those are things which are never going to get permission to actually be created. So in Christensen's view of innovation, this idea of permissionless innovation without permissionless implementation can't happen, because you need permissionless implementation to understand the sustaining innovations, and you will never get permission for the disruptive innovations because they're just not exciting enough when they're first created. Now let's talk about Simon Wardley's view of innovation. This is a really cool model. It explains so much about the Industrial Revolution, about all of innovation. I really, really enjoy this model. And what Simon Wardley says is that whenever something new is discovered, you have the genesis. You have the very first part, or the very first implementation of that. And people are like, wow, this is cool. And as they start to experiment with it, everybody's building their own custom version of this thing, whether that be their own custom version of a transistor or their own custom version of an electrical generator. And as people start to build all these different custom versions and the market interacts with that, what they realize is, oh, everybody's doing this custom thing and everybody's using kind of these similar components, and we can start to make products out of these. And as these products develop and they get cheaper and people even more understand them, they start to realize that all of these products are basically doing the same few functions that can be standardized. And that's when it becomes a commodity. So this is when you have a little wall outlet that you can plug into that gives you electricity. And there might be different companies running that wall outlet, but they're all working with the same standard interface, which allows, this is the important part, this allows the genesis of an entirely new type of innovation. Because once there's a stable component underneath, people can start building all sorts of things under this, and they say, wow, this is amazing. And the process starts all over again. And the important thing here is that at the first genesis of something, you don't have you have an innovation, but it's not innovation that can actually be used for anything. It's only through interaction with the market that you can start to get custom implementations, and it's only through interaction further with the market that you can start to get a product. And so, if you can't actually implement something, if you have created a commodity in the blockchain, but you're not actually allowing people to implement on it, then you're never going to get to the point where you actually get the sustaining innovation, because the innovation comes from building on it and then interacting with the market and see how the market uses it. So, innovation doesn't happen in the mind, it happens in the market. So you cannot have innovation without implementation. So the next part Paul goes into, and this part is important to me because this pertains exactly to what I'm building, is how oracles work. And essentially, the person chooses which oracle they want, the oracle reports on an event, and then the oracle is evaluated after the fact. And the important thing, Paul mentions this, and I want to mention this because I think it's really important, the next part of this argument, is that the payment happens here. The person puts up money first with their choice, and then the oracle gives them the answer. It's really hard to do it the other way where you pay them afterwards. And the different oracles have different varying quality. So in Paul's mind, there's actually an attack here with permissionless implementation. Because you can have Mr. Evil Red Guy, who is right down here, who says, I'm just going to take Mr. Blue Guy, who has really good quality, I'm going to copy all his reports, and then guess what? I'm just going to charge less for them. So I am always going to be cheaper than Mr. Blue. And because of that, Mr. Blue is going to go out of business, and I just pulled off a scam and made a bunch of money. And to me, there's kind of a fundamental thing that I'm confused about with Paul's thing here. Because remember, the oracle gets paid and then goes out and actually delivers the information. Which means, in order for Mr. Red to steal the information, he only can steal the information if Blue gets paid and actually goes out and gets the information. Now, if somebody pays Mr. Red instead of Mr. Blue, Blue doesn't go out and get the information, and Mr. Red just has to make something up. He's therefore unreliable, and nobody uses him. So what I don't understand, and maybe Paul, you can explain this to me, is why you think that it's Mr. Blue who's unsustainable. Because Mr. Blue always gets the right answer. Mr. Red only gets the right answer if Mr. Blue gets paid. His business depends on Mr. Blue. And as soon as people start going to him because they think he's good, they're going to recognize that he is not actually getting real information, and they're going to go back to Mr. Blue. So you say that this makes Mr. Blue unsustainable, but in my view, this makes Mr. Red unsustainable, because Mr. Blue has to get paid for Mr. Red to be able to do this scam. And once Mr. Blue stops getting paid, Mr. Red goes out of business, and Mr. Blue says, hey, I'm still here. Come to me. So maybe you can explain that to me, Paul. Now, there is a few, if I'm being really charitable with this argument, there's a few things that I could think maybe Paul was trying to say here that made more sense. So the first thing is that, let's say there's multiple competitors. Company A pays Mr. Blue to get the information, and then Company B just says, hey, you already paid. I'm going to use that information for free, and because I have now less cost than you are going to go out of business. And this is a possible attack that you could do if everything was free and open, and you could get everything from the blockchain that was available to everything else. Luckily, Ethereum has thought of this, and they have this word called private. And if you put the word private in your contract, it means that only the people who you say can access that data inside of the blockchain can access that inside of the blockchain. Now, it is possible to analyze the blockchain and still get that information, but that's possible in Bitcoin. And the whole thing we're arguing about here is getting that data inside the blockchain. So this is impossible. This is made impossible in Ethereum with one word, private. This attack is impossible. Now, the second thing Paul might be trying to say is if you're creating a decentralized oracle in which many people are competing to get reputation, then based on the reputation they have, that's how much money they get paid. And this is how TruthCoin works. And this is also how Crystal works. So Oracle B could steal the answer from Oracle A in a decentralized Oracle service, and therefore the reputation, and therefore the money. And this is very easy to present, and you know this, Paul, because this is what you do in your TruthCoin white paper. This is what we do in Crystal, is we create a simultaneous two-step game. In the first step, you submit your signed hash, and in the second step, you actually submit your answer. And so because the person cannot steal your signed hash because it's signed, they cannot pretend to have known your answer before you did, and therefore they cannot steal your reputation. So this part of Paul's argument I really don't get. He calls it the parasite contract, but again, to me, this totally depends. It totally depends on an unsustainable attack, because as soon as the real Oracle stops getting paid, the fake Oracle has no leg to stand on. So the real Oracle always must get paid. Okay, I'm going to skip this example. Paul himself says it's contrived and unlikely. I do want to mention that it's possible to make contrived and unlikely examples. Here's one by Vitalik, where you can change the block time, where you can print more Bitcoins, and that's just with soft forks. You don't need smart contracts for that at all. So I'm just going to skip this example because, like Paul said, this is kind of an unlikely example. You can play with it and do crazy things, but you can play with it and do crazy things no matter if you have smart contracts or not. Okay. So, again, we're going over costs and benefits here, and I think Paul misses a very, very clear benefit of smart contracts, which is that they allow of permissionless smart contracts, which is that they allow innovation, whereas permission smart contracts don't. Very important. You want innovation on your platform. Any platform that has innovation will beat a platform that does not. And so you want innovation on your platform. Okay, now Paul goes into this idea that there's nothing that's actually been created on Ethereum that can't be done in Bitcoin except for casinos. And again, this is just fundamentally misunderstanding how innovation works. So what's just happened in the blockchain space with Ethereum can be likened to when we first standardized electricity and we had plugs you could plug everything into. And before people, it wasn't just like, oh, you get plugs and now there's a computer. No, there was a lot of other things. People needed to start researching transistors. They needed to start mass creating plugs to plug in. And this is exactly what we're seeing in the Ethereum ecosystem right now. We're seeing these intermediate contracts, these things that are being built in order to allow innovation to happen on the platform. Things like oracles, things like blockchain explorers. These things are all things that need to exist in order to create the smart contracts that are going to be end user facing. And the reason we're seeing casinos is that you really don't need any of that stuff to create a casino. Everything for a casino is in Ethereum proper. You don't need oracles. You don't need really these crazy development things. You just need, Ethereum already has everything you need. So we're seeing those, but we're not going to start to see bigger consumer applications until the innovation has caught up with that, until we've commoditized a few other components that we need to do in order to build the consumer-facing components. So this, again, is just a fundamental misunderstanding of how innovation works. Okay, misunderstanding the trust problem. And this is a really good title for this slide, because I think there is a misunderstanding here. There's two different types of trust that we're talking about here. So one is the type that Paul is talking about over here. What Paul says is that banks and brokerage firms and lawyers, they need to be incredibly stable and well-defined. And if they fail, they're catastrophic. And this is why you need to be able to trust them not to fail. This is a really important type of trust. And Paul says you don't really need this type of trust for something like a restaurant. If a restaurant fails, you don't need to trust it not to fail, because another restaurant's just going to pop up in its place. And this is true. But this is not the type of trust that Ethereum is trying to create. There's two different types of trust here. One is just the trust for it not to fail. What Ethereum is trying to work on, the side of the trust problem, and here's where the misunderstanding happens, is not, oh, this can't fail. What we're trying to work on is that we can trust the control. In Ethereum's view, trust is about control. Who is controlling the product? So let me give you an example of this. Why was Android open source? Okay, why Google does not, the Google search engine is not open source. Google does not open source everything. Why did they choose to open source Android? The reason why is because it was a strategic move. What open sourcing Android did was make a credible commitment that they would not be the sole ones in control of the platform. Because what Apple was doing was in controlling everything. They were angering their users. They were angering their suppliers. They were angering everybody in the value chain, but they could do that because they had a monopoly on the market. And if Google had come on and said, we're creating our own browser that's closed sourced, no one would have switched over, because there's no credible commitment that Google wouldn't do the same thing that Apple had already done. But by open sourcing the project, what Google said was, we're going to put development into this, and if we are a bully like Apple is, then you can fork us. We don't have sole control of the product, so you can trust us to be honest, because we've made a credible commitment to do so that you can act on if we don't. Now, Google didn't do this with Google+. Why not? Because open sourcing Google+ wouldn't do anything. The thing that Facebook controls is not the software. The software is not the important part about what Facebook controls. It's the network of users and the data that Facebook has. And right now, there is no way to credibly commit that you won't be in control of the data and the users. But Ethereum gives us that. Ethereum gives a way to trust that I'm never going to take this data for myself. I'm never going to do what Twitter did and completely change my API because it doesn't suit the business model. I'm not going to take away the data that you had access to because it doesn't suit my business model. I'm not going to change the platform in a way that angers the users because it doesn't suit my business model. Because in Ethereum, you can program in the exact rules for when things change. Or you cannot program them in, and they can never be changed. And the data, you don't have control of, everybody has control of it. So the type of trust we're talking about here is the trust that I will not control what I'm creating for my ends instead of for the ends of everybody. And that's the type of trust that Ethereum is building, very different from the type of trust that says, this is not going to fail. Two different types of trust, and that's where the misunderstanding comes from. Okay, so again, this applies to Slockit. Yes, you can do this. So Paul here is saying that, why are we doing this with Slockit? This isn't going to fail. You don't need redundancy here for a lock. You can just use Bitcoin to pay people. You can use some sort of website to communicate with them, and again, then some sort of central company can give out these locks. Now, he might be saying that individuals can do this, but users aren't going to want to go create their own locks and do this. They're going to want a company to do it. The question is, who controls this whole process? If it's a company who controls handing out the locks and paying people and communicating between each other, what's to stop the company from saying, hey, we put out a new lock, and all our old locks you can no longer be paid with. You have to go get a new lock. Nothing unless you're using Ethereum. Because if you're using Ethereum, the company can make a credible commitment. They will not change certain things. They will only change certain things at the behest of the users. And this is the trust that Ethereum promises, and this is why Slockit is exciting to certain people. Okay, so what are we throwing away if we remove permissionless implementation? We're not throwing away oracles because, like I said, there's no way for this idea of a parasitic smart contract to really work. We already have brands, but what we don't have is brands who can make a credible commitment to not controlling things in a way that will help them at detriment to the rest of the ecosystem. Okay. Then Paul gets into this idea of feedback loops. And this is a really, really scary thing to me. I agree with Paul. This matters. Okay? When you have a system that is very, very hard to change and control, and that system is interacting in ways that you couldn't have previously expected, you end up with behaviors that you didn't expect, so-called emergent behaviors. And this matters. This is important. I agree with you here, Paul. But the solution is not to be really slow and careful with what you're bringing on. This is called the precautionary principle, okay? And the precautionary principle just says, don't bring new things on, don't make changes to the system until you're sure about them. So you can imagine this like a house of cards. You're very, very carefully building each thing and making sure that whatever you're doing is not going to knock over everything. But that's a very fragile way to build a system, because as soon as you put in one card that you didn't realize was slightly weighted one way, everything falls over. And this is compounded because miners aren't chosen for their ability to analyze game theory, for their ability to analyze these complex things. They're chosen for the computing power. And so not only is it fragile, but it's a fragile system built with inadequate controls. Instead, what I think you should do is have many different systems trying to prevent these things. And this is going to be the first thing we're going to build on Crystal. Once we get the main reputation system out there, what we want to do is build a system to verify contracts and to be able to blacklist contracts and to be able to update contracts if there are issues. And as we find the users who are better at figuring out which contracts had certain flaws or certain holes or misaligned incentives, those people get more say in approving new contracts. And not only that, but our system is going to be competing with every other system again, permissionless, so they're going to be innovating really quickly, that is doing the same thing. And by doing that, you end up with an anti-fragile system. If one person in our system is bad, you get another person. If our entire system is bad, you can use another system to do contracts. Whereas if you use Paul's system, you use this very fragile thing where you only have one level of security that is not paid to be that type of security. And then if it fails, the entire system fails. So again, I think what, Paul, you're talking about with complex systems and being careful with them is very important. I just don't think that this drive chain solution of having miners vote is the right way to go about solving it.
So let's analyze Paul's conclusion. First, he says, avoid the gray goo. Permissionless innovation equals good. Permissionless implementation equals bad. And as we went over earlier, this is a pipe dream. You can't have one without the other. Secondly, he says, contracts are on the emphasis of what can't be done. Allowing miners to ban things is appropriate because it's just a bigger version of what a normal contract does. This is true. It's also a more limited version and a more fragile version of what you can already do with permissionless smart contracts. He says, be careful about upgrades. And I say, instead, be careful about what you do with those upgrades. Have many mechanisms in place, permissionless mechanisms that people can choose to use that help prevent problems. And the market will sort out the best of those mechanisms. Thanks so much for watching, guys, and I'll catch you next time.